So welcome to today's webinar on Autodesk Inventor 2016 R2 and R3. My name is Matthew McKnight. I'm a Senior Technical Sales Specialist working from the Autodesk Melbourne office in Australia. If you'd like to contact me after this, feel free to reach out via email or phone. Alternatively, you can also connect with me on LinkedIn and Twitter as well. Okay, so let's just have a quick look at the agenda for today. So we'll do a brief introduction, then work through looking at the AnyCAD changes and a number of other changes that came about as a result of the 2016 release in itself. Follow this on with some of the additional features and functionality that came out with the R2 release. And then finally look at a couple of the new features associated with the R3 release. Okay, so just a little bit of housekeeping to begin with. So let's have a look at some of the support resources that are available to you as users of our software, and even just if you're interested in finding out more. The Autodesk Knowledge Network is a great place to go and look through in relation to products if you're trying to find specific information, such as what's new, help topics, tutorials, and the like. So you'll find a wealth of information in this area specific to Inventor, plus a lot of our other solutions. The Autodesk product forums is where customers can engage with other customers, but also with internal staff or internal Autodesk staff around questions around workflows, topics, issues, and the likes. And you'll also find that the TypePad blog is an area where you can access the latest information associated with installation and licensing of solutions. And finally, if you're just trying to keep abreast of all of the things that are happening with Autodesk and the things that are potentially affecting your industry, then it's worth looking at the Autodesk blog as well. Okay, so if you're trying to figure out how can you access the Inventor 2016 R2 and R3 release, there's a couple of short links there that'll take you to the locations where you can get further information and download the releases themselves, the updates. But alternatively, if you just in your favorite web browser do a quick search for either Inventor 2016 R2 or R3 update, you should be directed to those as well. Okay, so let's just jump straight in and start looking at some of the technical aspects of the releases, starting out with a few of the 2016 core updates that came out with the initial release. So AnyCAD is new functionality that has a new technology that's been incorporated in the 2016 release that enables you to reference third-party CAD files. So non-native CAD files is what the types of files that we're referring to here. So the likes of SolidWorks, CATIA, NX, or Creo files. Inventor now has the ability to be able to reference those files during the import or open stage. So in essence, what this is enabling you to do is then create a direct link without translating the file themselves. So there's now no longer the need to convert that file and save it in an Inventor file format. And this means a few things. That one, it cuts down significantly on the number of files that you're managing. Two, it means that you can handle it in much the same way as you would a native file. You can see here that the import dialog box enables us to select those components that we want to open. So if we've got an assembly, such as this SolidWorks assembly, we can specifically choose those components that we want to open and just open those ones to reference. And you'll see here that once we're inside that environment, changes that are made inside the native CAD system, in this case SolidWorks, are then updated inside of Inventor with a simple update, click of the update icon. This is fantastic because it means that the original file, if it changes for whatever reason, then the ability means that you can then simply update your parts through assemblies and drawings to reflect those changes as well. And it's not just limited to the part geometry as well. So in instances like this with SolidWorks, we can reference the custom properties that are associated with the part. So in this case, we've gone and updated the part to add some custom properties, and you'll find that that information is then linked through to the information associated with the bill of materials inside of Inventor. So extremely powerful tools and capabilities there with when it comes to managing non-native CAD files. There's also been a number of enhancements around the step format, and let's just look at those. So, firstly, everyone should be comfortable, or those people that are translating data quite regularly will be comfortable with the use of step 203 and 214 formats. Well, now there's a new format, which is essentially the merging of two ISO standards, and it's the 242 format, which is managed model-based 3D engineering. In essence, what this means is the new format is open to better PLM interoperability. It's going to enable more in terms of geometric dimensioning and tolerancing, and also better support for mesh data and the way that that's handled. Now, though some of these areas aren't necessarily applicable in the 2016 release, I suppose that gives you some insight into where potentially the product could be headed in the future. Also, in this respect, with the step format enhancements, there's now the ability to be able to export and import step Z files or a step zip file. It's a compressed step file. You can see here the advantages of doing that is smaller file size. So if you're emailing step files, then the ability to be able to compress that as in a zipped format enables you to easily transmit that, or much more easily transmit that. And you can look at it, the example given there on the screen, where we've reduced the size of a file from 150 kilobytes down to 32 kilobytes. So about 4 to 5 file size ratio associated with the reduction in file size. And further to that, you'll also notice that we can import now step Z files. So the only real proviso to keep in mind in this instance is the dialog box associated with the file location. In essence, this is where all of those files will be unzipped to. And it's important to remember that if there are files existing in that directory, the process of importing the step Z file will overwrite those files that have the same name. So keep that in mind when you go to import your step Z files. Okay, and further, and this really does follow on from the AnyCAD technology, is the DWG Underlay technology. Now, DWG Underlay is an associative link to the DWG format, and hopefully everyone is familiar with DWG format. But the best way of illustrating this really is to just show it in action. So it's an extremely powerful set of capabilities here. So if you're working with legacy DWG files or AutoCAD files, or maybe you still use AutoCAD as part of your workflow, then the ability to be able to use that is significant, because essentially you're creating a live link between the two file formats. So you can see here we've imported the DWG file directly inside of our Inventor environment. We can use that geometry like we can any other, say, sketch entity inside of Inventor, and create things like extrusions, cuts, revolves, and create geometry that's required. And you can even see here that we're linking through to a dimension to depict the thickness of the part. Now we go back inside of AutoCAD and we make a simple change by stretching the part. By going back inside of Inventor and hitting our update icon like we did with the AnyCAD file formats, then you'll see that that updates our geometry as well. So there's a link through to the original files that's maintained as a result of this. So a fantastic tool, not only limited just to new parts, but with inside the part environment, with inside the assembly environment. So extremely valuable if, like I said, you're working with legacy data or you're still incorporating AutoCAD with inside of your workflow. Okay, so let's have a look at Shape Generator, which was part of the R2 release that came out partway through last year. And Shape Generator is a new way of designing and analyzing your parts. It's part of what is often referred to as topology optimization, or more generally known as generative design. And it's a different way of analyzing your structures, where the software can give you some guidance on areas of your parts that material may not be required. So if we look at this process here, you can see that we analyze a generic part that we've designed. The system will come back and highlight areas or a more idealized shape of our part in areas where material may not be required. We then use that as a guide to then replicate that in our actual CAD geometry. And then as a final process, we would run off and analyze that design before potentially having it assessed by independent assessors and then tested under real world conditions. A couple of things to note: that it is a single part that an analysis can be conducted on. And then further to that, it doesn't eliminate the need for a full analysis. So it doesn't negate you to run back at the end once you've optimized your design, you've made changes to your geometry, for then to do an analysis, and further to that, do testing. Let's have a quick look at some specifics around Shape Generator. So you'll see here that the Shape Generator icon can be found in the 3D Model tab. But it can also be accessed inside of the Inventor simulation environment. If you create a new study, you'll see below the static analysis and modal analysis studies that there's now a new shape generator study that enables you to access the tools associated with running a shape generator study. And you'll see here it's a mixture of tools that you may be, if you've been using Inventor simulation, you may already be familiar with, and then some that you won't be. So let's run through some of the ones that maybe you're not familiar with, how they can be used. So there's now a preserved region tool that enables you to specify part of your design where you don't want material to be removed. It might be a boss, say, where a screw or a fastener is inserted, and you want to have material in that region, and as such you can specify that you want to preserve that region. Further to that, there's shape generator settings, and this is where you can set the goals or the target associated with the mass reduction. You can see here your original mass, your goal associated with the reduction of that as a percentage of the original, and then your mass target. Further to that, you also have your mesh resolution, which is where you can adjust that, maybe because of topology size, but also to look at the resolution in specific areas of your design. Let's have a quick look at how this works in a practical example. You can see here we've got a fixture or jig assembly, maybe a welding station, and we want to assess this bracket. Well, we can open it up and we can start analyzing the design quite quickly and easily. So as discussed, we can, inside the toolbars, get access directly to the shape generator environment. We can set up a number of typical constraints and loads. You can see here that we've constrained a number of bolt holes. We've also preserved regions around those holes as well. And now we're adding loads to the various mounting points of this bracket as well. So again, if you're familiar with using Inventor simulation, then a lot of what you've seen to this point is very familiar to you. Running the analysis, it's using the Nastran solver to solve this, and you can see here's an idealized shape showing geometry, recommended geometry. Now, it's part of the process is to then go back through and replicate this inside the CAD environment. So we then use that as a guide to then go and remove material and engineering judgment, obviously, to remove material from those areas where we don't think that it's required, add some fillets and any other features that are required. And then obviously the most logical follow-on step would be to analyze this design separately, confirm that it's, that the analysis, typical and traditional analysis, can validate the design as well, and then follow that up with any other requirements, such as structural analysis and then physical testing. Okay, so force effect, and this is following on from some of the simulation topic and theme of the shape generator. The force effect integration inside of Inventor has come about to add to the simulation capabilities. Hopefully everyone here has heard of force effect. It's used by millions of users, a lot of which is mobile users, and is available to anyone through a web interface online, enabling you to analyze static and kinematic structures very fast and easily. Here's a video showing the integration of that directly inside of Inventor. So you can see that those tools that you've become accustomed to using through a web or mobile interface are now available directly inside of Inventor. Now, there's no need to have a part having been created. It could be a blank canvas that you're creating your line elements here with, but you can then quite quickly and easily go and set up a static or kinematic assembly and analyze that structure. You can add things like dimensions, connection details, constraint types, load types, and you can see here a variety of different ways. From that, then you can analyze the structure, understanding things like reaction forces, bending moment, shear force diagrams, and the likes, which can be then saved out. And then from that, then you can look at then maybe optimizing your design. So in the first instance, we analyzed maybe a static analysis. Now we want to look at a kinematic analysis and investigate the association of a hydraulic or pneumatic cylinder. We can quite quickly insert that into our design, associate some parameters to that, and then run an analysis looking at the design requirement of what this cylinder needs to be spec'd as, so we can quite quickly see as a result what the output of that cylinder requirement would be. So extremely powerful tools, intuitive tools embedded directly inside of Inventor 2016 to help you analyze all kinds of structures. Okay, so let's have a look at the electromechanical workflow addition to the R2 release. Now, this is not to be confused with electrical functionality or the electrical mechanical workflow, as in cables and harnessing. Though there were some improvements to that in the 2016 release, the R2 release had new functionality that was specific to electronic mechanical workflow. So looking at the transfer of data between an electronic system and a mechanical system. So these new functionality enables electronic designers and mechanical designers to work much more intuitively and hand in hand and be able to share data much more easily. So let's have a quick look at that workflow. So here we have a design that's quite a detailed design of a connector inside of Inventor. Well, the good thing is now that we can use this connector detail and associate it with content center files. We can then do a import of an IDF file, and an IDF file is a standard translation file that most electronic design packages enable you to do. We can import that IDF file, filtering out the components that we don't want, and then importing the ones that we do. And you can see here, this is the population stage of the import, where we're importing the PCB and then populating it with the standard components. You can see that this will be a mixture of default components that are created from the IDF file, but also components that are imported from the content center as a result of the relationships that have been set up. So you can see that we've got footprints of width, depth, and height. But then if we look over and have a look at the connector that we'd previously associated to the content center is imported, enabling us to have some geometry that is depicting, footprint sizes and locations, but then more detailed geometry where required. So extremely powerful capabilities there with the R2 release, especially if you're working in conjunction or hand in hand with electronic designers. Okay, so let's have a look at the connected design features that were added to the R3 release, and this was came out at around towards the end of November, start of December of 2015. And these new features enable you to be able to share your information. It's leveraging the A360 platform, and hopefully everyone here knows of A360. Whereby A360 is providing you the means to be able to collaborate with colleagues that are maybe working in different locations, or your maybe suppliers or customers. So you can share your data in a manageable way that's very easy process to follow. And the collaborative aspect of it fits very well into the design process, because we have Inventor, obviously, for the detailed design. We have Vault to be able to manage and track change inside of our data and our systems. Now we also have A360 and the ability to be able to collaborate, share, and communicate our designs. So let's have a quick look at this process. And you can see here we have an assembly of a system set up inside of Inventor, and we're going to segregate that out and look at just the specific areas that we're interested in. We can then leverage this information and do a design share directly inside of Inventor, giving it a title and a description, and then generating a preview of what that share is going to look like. I can quite quickly add some email addresses associated with that share, and then you'll see that we've now transmitted that information to A360, which enables those contributors to be able to log in and access the design that we're working on. So in this case, we've maybe gone out to some colleagues and said, hey, what do you think of this design? Or to a customer, can you please confirm that this is per your requirements, and gather feedback from them. The initial workflow that you saw there was previously being run from a web browser, but it can be just as easily accessed from a tablet or from a mobile device such as your phone. So quite quickly you can come in here and be mobile out on a site, accessing the CAD data and contributing to the workflow and the design process here, adding comments to your design and not stopping, like that design process that's continual nowadays. So again, extremely powerful tool and additional with inside of the R3 environment is the ability to be able to use connected design. Now we'll add to this if you're looking for the icon, which is down in the bottom right of your Inventor user area. You will need to make sure that in the user interface icon that you have connected design on A360 turned on. Okay, and finally, IFC publishing for building products, which was another addition as part of the R3 release. IFC is a data exchange format, which is for mechanical engineers that aren't all that familiar with the building industry. It's very similar to, say, STEP or IGES. It's a neutral file format, and it's part of the BIM or building information modeling workflow. So the addition of the IFC format is further to what you already have available, which is RFA and ADSK export formats. A couple of things to note here: that it's powered by the Revit engine, and it's also been certified as Building Smart as well. Okay, so further reading, if you want to get some more information associated with some of the topics that we've talked about tonight or something else, feel free to check out the Inventor forums. You'll find a host of information here. Like I said a little earlier, our customers, our users are often using this as a means to talk with one another and talk directly with Autodesk staff around topics, workflows, problems that they're encountering and the likes, and give feedback on our solutions. You'll also find that there's an Autodesk Inventor Twitter feed where you can get all the latest information around Inventor-related releases, as is the case on Facebook. So you'll find that there's an Autodesk Inventor Facebook group or page. If you're after something a little bit more local, you will find that the Australia-New Zealand technical team here is looking after an Autodesk YouTube channel. And you'll find that you can subscribe to that and get all the latest videos, technical videos related to releases such as the ones that we've talked about today. And a little bit, along the same lines, we have a Future of Making Things group inside of LinkedIn. It's not very product specific in the sense that it's not just talking about Inventor. It's more talking about changes to industry, technology that's changing the manufacturing landscape, and especially and particularly looking at those that are specific to Australia and New Zealand. So if you're on LinkedIn, please follow that group. It'll be worth your while. Finally, if you have some follow-up questions, feel free to contact me. My details there on the screen. Feel free to email, call, or connect with me on LinkedIn or Twitter. Otherwise, I'll take any questions after the session. And for now, I will thank you for your time and wish you a good day. Thank you. Bye.